.NET Tooling with Chet Husk.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that AI, Azure, and the .NET ecosystem has to offer. My guest today on the show is Chet Husk, and he's a product manager on the .NET Tools team at Microsoft, where he leads the .NET SDK, MSBuild, template engine, and install scripts teams. And that really shapes how millions of .NET developers build and publish and containerize their applications. But before joining Microsoft in 2021, Chet was deeply embedded in the F# open source community, serving on the F# Software Foundation board and co-maintaining Ionide, the popular F# extension for VS Code. And at Microsoft, he's driven the built-in container publishing support that lets developers create container images with just running .NET Publish, which really makes it where there's no Dockerfile required. And he's recently shipped SLNX, the new XML-based solution file format for the .NET CLI. He's also exploring the intersection of AI and build tooling with an open source MCP server that lets AI assistants analyze MSBuild binary logs. So a lot to talk about. Chet, welcome to the show. How are you, sir?
I'm doing well. Thanks for having me. Yeah, you teed me up pretty well there. Where do you want to start today?
My pleasure. Well, hey, you've done a lot. There's a lot to talk about. Before we get into the technical stuff, I just saw each other in person at the MVP Summit about a month ago. But for a lot of listeners who haven't seen you speak at conferences or .NET Conf or all the other places, I always like to help them get to know you a little bit. So if you were to kind of go back in time, is there any turning points in your career or things that stand out to you that have really gripped you where you just get up every morning jazzed up about custom software?
Okay, so this is going to be a little bit of an esoteric one, but it was builds. It's always been builds for me. Okay. And that's kind of weird. At every job I've ever had, like back before I joined Microsoft, I was a developer. Right. And a team lead and like the build guy at basically every job I've had. So it was always correctness, consistency, determinism, and how to make things faster and easier for everybody at that sort of fundamental level. And so that's the thing that sparked my fascination with F# in the first place. That's a thing that was useful to know to be able to write F# tooling, because in .NET, you need to interact with MSBuild to get critical data about the projects you're working with. And then from there, it just kind of naturally fit into the need that Microsoft had for a PM working in these areas. So it was a really clean fit for me. And it's still something I wake up every day excited to try and tackle and make better for the entire .NET user base.
Nice. Yeah, I do remember a time when there was the arguments about how Visual Studio built .NET, and then there were differences in how the command line built .NET. Now, those days are mostly gone, but yeah, those things are really important.
That could be an entire multi-hour conversation by itself. So, yeah. And that's something we still work with today, but you're right that the goal is consistency of experience between those, at least in certain scenarios, right? Yeah. There are things that IDEs want to do to make the like hyper inner loop experiences, like typing one character and getting feedback faster, that don't necessarily mesh well with making Control B or Control Shift B faster and work well.
Yeah.
Right. So there's still some tension there, but you're exactly right. We've gotten so much more aligned than we were in the past.
Well, so you brought up this term inner loop, and I want to ask you to dive into it and see what your worldview is. And I'm thinking specifically about just the concept of there's some type of change at some level, and at some point we get the answer to the question, did what I do, was that a good solid step forward, or did I accidentally take a step backward? How do you think about that concept, like the inner loop, and then the the middle loops and the outer loops. How do you think of that in your mind?
Well, first off, I think about it a lot. It's one of the biggest areas of investigation and analysis right now inside the tooling org at Microsoft, because it's becoming more and more critical with AI agents. Right. If you think of how like a classic VS-based editing experience would go for a developer, there are a few different sort of rings of changes. There's editing some code, like no package changes, no project file changes, nothing like that. And that typically has a pretty fast inner loop because all of the characteristics of your project, its dependencies, the compilation flags, et cetera, have remained the same. And so all you need to do is you need the Roslyn compiler to type check that and tell you if you've made any mistakes, run any analyzers, et cetera. That's like the hyper inner loop. And then from there, you have sort of the next level of inner loop, which is I want to run a full build. I want to build this the way the command line would to get a higher degree of certainty or to apply some level of analysis that only happens during a build as opposed to like a minor edit. That's like the middle ring. And then the outer ring is your CI/CD, where things are typically fresh every time. So those are kind of the very coarse groupings that I split things into. But even within those categories of changes, there are degrees. Especially in our ecosystem, changes that only change like a package reference can require a large amount of work. You have to do a full NuGet restore to analyze the impact of how that package reference propagates through your entire project dependency graph. Because that new project or package reference could introduce new constraints on the transitive dependencies. So dependencies of your direct dependencies. So that's a big operation, and that can take quite a while. So that's a very impactful, like mid-loop change. A less impactful one might be adding a compiler define because you want to feature flag a chunk of code, right? So I sort of group the category of change in these buckets, and then there are different strategies that you can use to make each of those buckets faster. The IDE and recently like .NET Watch, for example, have done a really good job of detecting those real inner loop changes, like code edits that do not touch project files. They're very good about caching that state of your project, like all the information that the compiler itself needs, and then only rerunning the compilation or the type checking to give you feedback, doing the minimum amount of work there. Where we start struggling and where a lot of focus is going right now is when you make project-facing changes, or you add new projects that introduce new project-to-project dependencies or things like that. And that's when you start requiring build-level work to happen. And so that's an area of a ton of investigation right now, because even though MSBuild is an incremental system, it's very possible to have MSBuild targets that don't behave well with incrementality, and so require you to do more work than you would expect on a build, or that are like don't pay attention to incrementality at all, or are too finely grained on their incrementality, and so MSBuild never is able to reuse work that it's done. So MSBuild's incrementality model, and also the amount or the fact that MSBuild is largely stateless, means that repeated build invocations have to do more calculation each time you invoke it. And so reducing that amount of rework and improving the incrementality of the system to us are things that we view as critical to making the build loop faster. And yeah, so this is, like I said, a big area of interest for us because of AI agentic-based workflows. In a VS or IDE-focused world, you typically have one user working on some stuff and triggering a build. But in a multi-agent, like multi-work tree mode, each of those agents can be independently building. And MSBuild today assumes it has full use of the resources of the system. And so we have teams building multiple hundreds of project repositories 4 or 5 times simultaneously because they have multiple workflows going, and it just drags their machines to a halt. So making our entire tool chain, not just MSBuild, but Roslyn and the analyzers and whatnot, work better in a concurrent user scenario is like job one today.
That's a good point. That's a good point, because right here on my computer, I have like three different AI tools that are going. Now, they Yeah, they happen to be in even different Git repositories, but you're right, they're all running .NET.exe.
Yeah. And so this is an entire like implicit philosophy that a lot of our tools have had. One user asking us to do something, so we need to devote the entire resources of the system to accomplishing that goal. And that just doesn't work well when you have 2 people or 4 people or 8 people wanting things. So we're looking at things like central coordinators or ways to automatically load balance in ways that are transparent to the user, so that user behaviors don't have to change to pick up the benefit of the feature. And that's like the real fine line. It's very easy to make a feature that somebody has to change their behaviors to opt into, but the real benefit is when the simple thing, the thing we've trained the ecosystem to do, can just inherently pick up the benefit.
That's a good point, because if you did do something that required all of us to one, know about it, and 2, change something, how many years would that be to just finally get to 30% of the industry knowing that, oh, there was something that I needed to do different? It just doesn't work.
So, and now you're getting to my other pet topic right now, which is like acquisition and education. The .NET toolchain right now releases on roughly a quarterly basis. We've got the GA release of the 100 feature band of the tooling in November. We typically have a 200 release in February, a 300 in May aligned with build, and then a 400 in August. These tend to align with VS releases. That's a little bit more muddy these days now that VS is on a live service model, but we at least are maintaining that cadence for now. But that limits the rate at which we can ship these new features. It makes it harder to like A/B test or ship experimental features to users. But that cadence is also like, it makes it difficult and easy for us to get behind on things that need to move rapidly. Like, so as far as education, it seems like the way to go for education now is documentation and skills. Because if you have skills and you can connect those skills with an agent, then the agent can immediately benefit from whatever new feature you've added. The problem is that like the rate of change of like where you put skills or what their format should be or how to tune them for the models and agents that are popular today changes faster than our release cadence. So broadly, the topic of how people acquire and interact with our tooling and how we can accelerate that while not reducing the quality of the releases that we do is like very top of mind for me. This is like the core thesis behind the talk I had at MVP Summit that will hopefully, well, it's all open, but the .NET Up acquisition project.
Yeah, that's
is kind of at the core here.
Yeah. Okay, so speaking of what people need to do differently or know about, this is not new news, but a lot of people don't know what the heck SLNX is. Now you've put it on your blog. It's a new extension to our Visual Studio solution file. So can you give us the rundown of why there was some format change needed and what people should know?
Oh, yeah. So we've had classic solution files since Visual Studio was a product, right? And if you are a long-term .NET user, you're familiar with merge conflict hell that comes out of that. You're familiar with the pain of like keeping the solution structure up to date with whatever file system structure you've had. You're familiar with trying to rename projects in non-IDE based tooling and missing a place and your solution being subtly broken. It's just not a good authoring situation. And so we, as is our response, have built tooling around it, right? Actions that you take in the VS Solution Explorer modify that file for you. The .NET CLI provides commands that you can use to correctly add or remove projects from a solution. But that still wasn't enough, because even if we could make sure that you could edit that file correctly all the time, you still had to deal with merge conflicts. And if you ever mess those up, all of our tooling just broke. So the Visual Studio Solution team had this thought that we can modernize this format. We can keep the same logic and the same content, but we can learn the lessons of the project file simplification effort that happened around the time that .NET Core 2.0 was released. I think 2.0. It was either 2 or 3. It was slightly before my time. But we can learn the lessons of that, and we can simplify and just remove the need to put in data that is able to be defaulted. And so with that and a couple other smart design decisions, we can give a more structured data format that is easier to merge, easier to manipulate, and easier for humans to read. And that's the whole point of SLNX files. It is the same data model as solutions. In behavior, in how the IDEs see them, it's all the same. It is just a fresh coat of paint to make it easier to work with. And as of, I think, .NET 9.0200, the .NET CLI fully supports working with SLNX files. There are templates built in, so you can start a new project with just .NET New SLN, and there's a format option you can use to choose. Starting in .NET 10, the default of that option, or the default of .NET New SLN, is a SLNX. So we're trying to put you on the happy path. All of the .NET CLI solution manipulation commands work with SLNX, and all of the major IDEs that we ship support them. So you can use them successfully in DevKit, in Ionide, in VS, and in Writer, and all of the tooling. Mm-hmm. If you are using the Roslyn Workspace or MSBuild APIs directly to interact with solutions and projects, it also just works there. So it's a consistently supported solution across all of our tooling, no matter how you need to interact with it. I 100% suggest everyone go migrate, and you can actually migrate easily either from within Visual Studio or from the .NET CLI, because we have a .NET SLN migrate command that will do it for you.
Nice. Yeah, I've been using .NET since the first version, and this one scenario has always been tricky, is when whether it's a proof of concept or a new application, anytime you do a new project, the solution file invariably gets put in the same folder as whatever project happened to be first, and then you have 3, 4, 5. You add other projects, and you're like, oh shoot, I got to reorganize that. I need to pull the solution up one folder, and then it's manual text editor. So that's burned into my brain.
It's kind of rough. If you don't want to use the .NET CLI to make the solution file and then .NET solution add all of your projects, there are some great projects out there. There is the SLNGen, so SLNGEN .NET tool that you can use. You can point it at a directory and it'll find all the projects, and it will create a solution or SLNX file with all those projects just to kickstart you.
Nice.
A lot of people use it for other reasons as well, but that's a simple use case that is easy to get started with. What else? We're investigating some other ways of working with projects as well. If you've used DevKit recently, you may have seen that they're pushing for a more workspace-centric way of working with .NET projects that supports solutions if they're there, but doesn't require them. Mm-hmm. And so that is leading to some discussions internally about, right now, one of the limitations of MSBuild is it requires one buildable thing to interact with. And that thing could be a solution or a solution X or a project or a number of other formats. What if we made it possible from the MSBuild command line and the MSBuild APIs to easily work with multiple things, like a glob of projects? What would that do to the user experience? And would it reduce potentially the need to have solution files? So if you're familiar with other ecosystems, not all ecosystems require a workspace level orchestration file. Some of them are able to sort of synthesize that. And so we're looking at reducing the need to have this variety of files just to make a .NET project space work.
Yeah, good point. Well, earlier on, you kind of threw out AI and workspaces and all the tools. So I know this is so new. We're not even a year in to the world where we let AI do the code instead of hand coding it. So super early. But how is the .NET tooling having to change when more and more of the invocations of it is just another computer program instead of a person in the IDE?
Oh yeah, this is a huge topic. So first and foremost, the performance, it becomes more and more important when you are having multiple simultaneous users that commands are fast. And for better or for worse, in our tooling ecosystem, that means MSBuild needs to be fast, because many of the commands that you will do at the CLI, which is the interface that most of these agents are going to be using, they use MSBuild in some way or another. So adding a package, for example, after you add the package, it performs a restore to ensure that you have all of those packages down. So restore and the MSBuild portion of that and the actual restore algorithm part of that need to be fast. When you are making a code change, oftentimes the agents will apply a bunch of edits and then run .NET Build. to do that. And so .NET Build needs to be fast. This comes back to the sort of improving of incrementality so that less work needs to be done for a build like that. Because in the most extreme case, if all of the edits were code, only the C# compiler potentially needs to be run in order to get feedback.
Yeah.
And maybe even more so, only the C# compiler on the project you changed needs to be called.
Yeah.
Right. So we do a lot of things in MSBuild and in the .NET SDK automatically that are nice when you are a user that just wants to make sure a thing works, but are costly when you are an automated agent running things repeatedly. Favorite example of this is every build or publish or any test command you run does an implicit .NET restore just to make sure you have all the packages there. But if you haven't changed your projects, that is a cost to you. And so one of the ways we are seriously thinking about changing the tooling is like making the IDEs able to like set flags and change the build such that restores only happen when the IDEs think they need to happen.
Yeah.
Right. And in skills that we give to agents, we want them to know that when you're doing inner loop builds and you haven't changed package references or project references or project configuration, you can add a no restore on there and save some time flat. You can also add certain MSBuild properties that change the way the SDK behaves. So when you build a project, by default, it is going to go through and recursively build all of your project references. But if you, as an agent or a human, know that those haven't changed at all, you can pass a property called build project references equals false to that build, and MSBuild won't even try. It will just assume that its necessary dependencies for this project are there and go about its business. And even if those sub-project builds were perfectly incremental, that's still computation that has to happen.
Yeah.
Right? So knowing something about the context in which this build is requested means that we can change our behavior to optimize for it. So a lot of our discussion right now and a lot of our fact finding is like, A, how can we know we're in these different scenarios? Or how can we tell the thing that's running the builds what knobs are available to optimize the build without sacrificing correctness build?
Yeah.
And then secondarily, there's like the efficiency of the build process itself. My favorite thing to harp on right now is like a lot of people like to use Git version or similar tools to ensure that their assemblies and their packages are stamped with a commit SHA on them. This is great from a traceability perspective, but it's horrible for inner loop because the way that actually works is we generate an assembly info item that gets inserted, like compiled into your project, a C# snippet that gets compiled into your project. And there are MSBuild properties that flow to the actual Roslyn call that have that version in them, to say nothing of that version being flowed to NuGet package commands, right? All of those are changes that require work to be done, which means the actual compilation has to be redone. There's a world in which we could change the way that we do these like almost post-processing tasks because we could just inject some IL or change the PE metadata tables to set that version on an assembly that was already compiled and save that actual compilation and just do the restamping, right?
Oh,
so some rethinking of how we have tended to make these monolithic build operations, breaking them down into parts that can be more independently cached and reused. That's some of the thinking that's going on now too. And you take that out to its like final conclusion and you get things that look a lot more like the way trimming and publishing work today. So when you write code that is trim friendly today and you've got like your runtime guards and you're delegating to this implementation on Linux and this implementation on Mac OS and this on Windows, when you then go to trim, the base assembly that you're putting into that trimming process is platform agnostic. In most cases, it has all three of those branches. And all that's happening is a post-processing step that is recursively like eliminating branches from that DLL based on knowledge it has about the target.
Yeah.
And you get a transformed DLL out of that. And that is like a declarative inputs to outputs process that is definitely cacheable. So anyway, that's my favorite thing to harp on right now.
That's a lot. You mentioned AI skills and different ways to use it. And of course, when we think about just a skill that I might learn, first there's an awareness that, hey, there's a new skill that I need to learn, and then you kind of dive into it. But when you're talking about AI skills, and then you talk about trimming, I want you to test how I'm thinking about this concept. It seems that for a long time, whether it be trimming or something else, I needed to learn the syntax of how the tooling needed to be operated in order to do the trimming, tree shaking, any number of these operations for different platforms that were important, that yielded a smaller software package, smaller memory footprint. But now with AI, it's almost like, at least in my mind, I want you to test me on this, I need to be aware that that architectural concept exists, and that for the different platforms, it's a possibility and it's a good thing that I can make my software package smaller startup memory footprint, but I don't actually need to know the syntax of how the tooling needs it. I can put that in a paragraph in this concept of an AI skill, and the AI tool will kind of look up the syntax and just do it. How am I thinking about it?
Definitely, that is the promise, right? It can be an abstraction, right? So you are thinking in terms of behavioral characteristics of the software that you're writing. I want it to be native. I want it to be optimized for startup times, because it's going to be used in an environment where it needs to rapidly start up, do something, and then get torn down, right? So if I'm thinking about a new project and starting one off with AI, then what I'm thinking is like the intent of the project. If this is a back-end service, it needs to have certain characteristics. If it's going to be a Lambda function or an Azure function, it has different behavior characteristics. If it is a client-side app, it has these characteristics, right? A good skill would start with that goal that you have and help you decide what the appropriate deployment and publishing mechanism would be. And sometimes this will be constrained by the deployment mechanism you've chosen. And sometimes you might have multiple options there, right? For Azure Functions, you have both an out of process and an in process model, and those have different constraints and characteristics. The out of process lets you use trimmed and AOT, and perhaps liberates you from the versioning constraints and deployment constraints of the functions platform. Mm-hmm. But you're shipping larger packages overall unless you trim. Right. Whereas the improc model, you don't have to care about dependency updates, and you have a different kind of performance characteristic to that. Right. So I like that having a skill can allow the developer to think more about their end goal and the behavioral characteristics and the user-facing characteristics of the system they're trying to make without needing to know all the nitty-gritty. But to me, it is just a shortcut for how I would have been thinking about the problem in the first place. I want this. This is a short-lived application. I want it to spin up quickly. What are the things I need to do that? Oh, here's the publishing, or here's the doc about how to package and publish an application on MS Learn, and it's telling me about the trade-offs between my options. Mm-hmm. The skill is just gluing those steps together, in my opinion. And in some cases, if you go look at the .NET/skills repo that my boss Tim Hoyer and others have been curating and contributing to, in many cases, what you'll find there are pointers and summations of data that we have on Learn already, right? We're finding more and more that this practice we have of trying to document consistently and having a good canonical source of information for these fundamentals is valuable in this age of AI. It's just about connecting the dots between the systems.
Okay. So speaking of skills, you mentioned the .NET/skills GitHub repo, and lots of people are sharing this concept of skills. What is, from a tooling perspective, what is the proper method that people should be using in order to connect or reference the right skills so that the AI tool can pull them in and use them?
This is going to depend. It's going to change depending on what agent tooling you're using. There are kind of emerging standards. Like if you remember that there used to be Copilot instructions and there were Claude agent instructions, and now we're slowly starting to converge on Agents MD and others. Similarly, for skills and sub-agents, there are emerging standards. So I'm not intimately familiar with what those are today because I've let the folks over at .NET Skills handle that for me.
I mean, weeks have passed. Weeks.
Yes, it is. It can be a lot to stay on top of this. But I think what you're getting at is what is the distribution and update of these things, which is also an emerging space. Claude, for example, has an auto update of any plugin marketplaces that you have configured, and Copilot, I believe, is like allows you to manually update and is working on auto update. You can reference like versioned entities from plugin marketplaces, or you can add plugin marketplaces from GitHub repos. Like there's a whole bunch of different ways to acquire these things. And then it becomes like a locking and like version control problem, which we all love.
So you mentioned reference. Where are these references? We're used to project references and DLL references and NuGet. When you say reference, where is that reference configured in the current tooling?
They are somewhere in the state of these tools. So if you go dig around in like the Copilot state directory, depending on the scope at which you have configured these plugins, they will either live in a directory inside your repo and be like have tagged data there that says this came from this GitHub repository at this revision, or this plugin marketplace with this version, right? And that'll be in your repo. If it's at a user level, it'll be somewhere in your user level state for that tool. And it'll either be scoped to a particular repository or it will be global to all repositories on your system. So like obviously if you're going to be sharing across team members, you're going to want to have those things configured at a repo level. I believe Copilot even allows you to do this kind of configuration at a GitHub org level as well, which can help. So that's one example in which the sort of ubiquity of Copilot can be helpful here, and the sort of integration between GitHub and Copilot can help manage this kind of stuff. There are other ways to distribute skills, though. I hesitate to endorse this, but I just learned about it yesterday, and it only made me throw up in the back of my throat a little bit, so I want to share it. There is an enterprising developer. There's at least one package out there. So let me back up a bit. NuGet packages can contain build logic.
Yeah. Mm-hmm.
And this build logic will run during your build. And by the act of adding a package reference, you are letting someone potentially change your build. So big warning there. This is how packages, right? That has always been the case. That's how like min version and git version and a whole bunch of other plugins work. Heck, that's how the SDK containerization worked in the first release. We published a package, hooked publish. But this developer made some targets. So they bundled a skill in their package and they made a build target that ran during your build and copied that skill from the package into a repo local location in your repo.
Yep.
They did it well. There's good incrementality. So it's not going to like blow up your build, like rebuild performance or anything like that. But it was the first time I'd see someone take advantage of one of the features of our platform to tightly integrate with an agent experience. It is the struct ID package from the developer called DevLooped. I can copy a link into the chat here.
Yeah, we'll include that in the show notes. And
sweet.
Well, I mean, NuGet packages can contain content. They can contain PowerShell scripts. They have an install script where when you pull it in, I mean, these little triggers are kind of part of the NuGet architecture. And the thought is, okay, there's no way that, we need some way to publish, version, and rev. I mean, if I need to update something, NuGet package management, okay, that makes sense. Also, the .NET SDK, I'm thinking, it's invariable that at some point the AI tools will do .NET.exe with some command line switch and say, hey, give me the skill for how I should use the current version of you.
Mm-hmm. Yeah, this is so. You don't always need skills for things. And this is an area that I'm interested in as well. Oftentimes, if your help output is good enough and provides examples and enough context in and of itself, the tools today are very good about connecting the dots there. And so a few minutes ago, you asked, like, what are we doing at the tooling level to adapt to this world? Well, one part is skills for lesser known functionality. Another part is changing the output of the core tools to be more useful. I don't know if you've looked at what you get out of, .NET random command -- help today, but the usage that you get is very bare bones. It's almost like I think it's a EBNF grammar that you get. So it's very academic in terms. And one thing it does not consistently have is examples of specific use cases and combinations of flags and arguments that lead to certain outcomes. So one thing we want to do is make sure that we have examples in line with descriptions about what they do to make the AI or the agentic tools more aware of common patterns there. There's also like a revamp that we have to do around the way that input and output are handled globally across the .NET CLI. It's kind of a heterogeneous application today. It is a grown and not designed tool in several ways. Multiple teams contribute to it. And so one of the things we've been trying to do is establish common UX patterns and roll those out to the different parts of the application. But then there's still MSBuild. Sometimes MSBuild and the output that it displays today is one of my favorite examples of optimizing for humans to the detriment of agents. So in .NET 8, we introduced a new output format for the build called terminal logger. And in 8, it was off by default, and you could opt into it with -TL. And the whole purpose of this output was to get rid of a lot of the noise that showed up in a build and give you something structured that made use of terminal capabilities today to give you better glanceability about what happened. So we try and show you the primary outputs of a project. We try and group the diagnostics for that project underneath each one. We try and give you at-a-glance information about how the projects were built, target frameworks, runtime identifiers, this kind of thing. And then at the bottom was the real novel part, because in the previous loggers, you only got data after each target or task or project completed. And so with the terminal logger, we added a live update section at the bottom that showed you what each of the MSBuild workers was doing at that time. And this could be used to at a glance say, wait, I'm seeing this project spend a lot of time in like the static web assets task or this containerization task. Should I be seeing that this often? Is there a perf problem? Do I need to raise an issue on the SDK repo? Have I done something that's messed up my build, right? The idea being that surfacing this information would lead to investigations. That feature is implemented using VT terminal codes that are literally telling the cursor to go back to the start of the line, erase it, and like write out a new set of data. That's very token inefficient. And so what we've tried to do is make features of terminal logger toggleable and then discover or infer when we're being used by agents and toggle off the features that are token inefficient. So this is an example of us trying to be more contextually aware of how the tooling is being used and optimize our output for both token efficiency and having enough useful context that the agent can follow on from that. So reducing waste is one part of it, but another part of it is seeing what we can do to provide more like Rust style context around errors. I don't know if you've ever built a Rust project before, but when you have a compilation error in a Rust project, you get these beautiful terminal graphs, like highlighting the chunk of code that was wrong. You get an error code, you get a description of the category of error that is, as well as recommendations about specific things to do to fix it. And LLMs can take that payload, either formatted as it is or in another structured format, and be better about fixing it. And that's a thing we want for .NET's ecosystem as well.
Yeah, that's a lot. That's good stuff.
There's so much stuff.
As we close up here, I'd like to kind of bring it down to something really practical that we can leave all the listeners with. And this goes back probably any .NET version. New computers are fast, but everybody has different computers. And it's unclear if maybe going from 16 to 32 to 64 gigs of RAM is going to, make .NET faster, like the inner loop for them, or if it's better to look at their hard drive and see, can I get a hard drive that has faster speed? So what's your view of that, and what has the biggest impact on just the speed of when you run .NET.exe or MSBuild?
The number one thing you can do for yourself, if you don't have an SSD today, please, I'm begging you, get one, regardless of platform you're on. Next is if you're on Windows, please make a dev drive. I cannot stress this enough. Dev drives are so much better for working with .NET and any development tool of any kind. In the experiments I've run, just moving a code base over to a dev drive and building it there can result in upwards of 20% improvements on build speed. And this is all down to dev drives using more asynchronous NTFS file drivers than the synchronous ones that are on a non-dev drive.
No.
So to do this, I think you have to go enable developer mode on your Windows workstation, and you have to create a new partition or thing. There's docs. Go find the docs. Do a dev drive. Put your code on that. You will love yourself. And if you can, also put your NuGet packages global directory on that dev drive. That'll take a modification to your global NuGet configuration, but you can do that via the .NET NuGet config command. So set that up, and all of your file writes will be so much faster, and you will also get what's called a copy on write file system. So copies of files from a source to a destination won't actually do any work unless that file is changed in some way. So you get massive speed ups there as well. If you are on Mac OS or recent Linux systems, you probably are already on a copy on write system and are already getting the benefit of these. So Windows users, please dev drive. So those two things are the most impactful things you can do. More than CPU cores, more than RAM. And the reason for that is because MSBuild is a parallel system, sure, but your workspace may not be parallel enough. If you just have a couple projects, having 18 MSBuild workers isn't going to really change anything, because MSBuild schedules work by the logical project. And once a logical project is assigned to a worker, that worker will always work on that project. So if you have very wide and shallow project graphs, then more cores can help. But for most people, I think that is not especially true, because most people, especially in like in-tier architectures, will have like taller, more narrow graphs.
Yeah. All right. Well, that's useful. That's great. I think everybody, I hear all the listeners scrambling to to check on these things now. So,
if you're not sure, you can get what's called a bin log. You can do any build or most build using operations on the .NET toolchain. You can add -bl as an argument to them, and that will give you a file called msbuild.binlog. And then you can go grab Kirill Ozenkov's structured bin log viewer, and you can open that file in that viewer. And at the top of this file, there will be a number of messages that are looking at the execution environment of the system and saying, you know, if you're on Windows, is long paths on? Is secure access blocking file writes and causing slowness? Are you on a dev drive? Like these detections are in the bin log, and they can help you quickly see if you're leaving performance on the table.
Yeah, awesome. Well, Chet, thanks so much for coming with me on the podcast and having this great conversation. I appreciate it.
It was a pleasure. Thank you for having me.
Oh, my pleasure indeed. And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.